Thank you for choosing to watch this video on understanding RFI. RFI is an acronym for RF Inspector. RFI is the spur analysis tool for VSS. In this project, we have two identical system diagrams, RFI Test 1 and RFI Test 2. If we look at the resulting spectrum plots, we'll see that RFI Test 2 is generating more spurs than that of RFI Test 1. The reason for this has to do with the settings for RF Inspector. If I go to the options for RFI Test 1, you'll see here under Frequency Settings, I have a constraint for the harmonic band DC to second harmonic band. The options for RFI Test 2 are indicated here, and in fact I do not have a constraint on the harmonic band. To apply a constraint, I left-hand mouse button to put a check mark in the box, and then I set the constraint. I'll set it here to around fundamental only, run the simulation, and clearly we see that RFI Test 1 is generating more spurs than that of RFI Test 2, and in fact the products being generated by RFI Test 2 are just the sum and the difference, and we can see the yellow leaking through as well. For the rest of the video, we'll work with RFI Test 1 and look at the settings under RF Inspector. And in fact, the first go, we'll put a no constraint on the harmonic band and run it, and we see more spurs being generated, more intermodulation products being generated. At the second go of the simulation, we'll go here to the parameter called component limits, uncheck that, maximum harmonic generated, and once again we see more spurs being generated. The reason for this has to do with the settings of the mixer, and in fact if we look here at the parameter page of the mixer is currently configured to generate up to the 10th harmonic of the LO and the 10th harmonic of the input. Therefore, when we run the simulation, RFI will go from take that into account and generate the corresponding spurs and intermodulation products. Going back here to the options for RFI Test 1 and looking at the parameter called noise floor, presently RFI will generate spurs all the way down to minus 184 dBm. If I select another value such as minus 40 dBm and run the simulation, you'll see here that no spur goes below minus 40 dBm. Looking at the system diagram once again, you'll see here this equation, LO harmonic max plus 1 times NH max plus 1 must be less than or equal to 121. And once again, those parameters here are controlled in this window and can be manually set to any value you choose as long as you stay within the constraints of this equation. Now, if we look at the system diagram, we also note that we do have an M probe here. The M probe allows you to monitor the spectrum at any output port of a component. So if I move it over here to the output of this tone source, we will see here the 1.8 gigahertz signal at 0 dBm. And if we go back to the output of the mixer, there we are as we before. And in fact, if you already worked with RFI before, this might be some redundant information, but you can go to any spur here in the spectrum plot and double click on it, and you'll get here the RF Inspector Heritage window, and you can use this window to see what components contributed to that signal being at that particular power level. For more information about RFI and, in general, RF modeling in VSS, please select Help, Getting Started, and go to this chapter here, VSS Modeling Guide. Under RF Modeling, you'll find information about RF Inspector, as well as information about other simulation engines in VSS. For more information about VSS in general, please visit our website. Thank you for watching this video. I hope this brief explanation of RFI settings helps you understand VSS